Welcome back to Western Washington University in our computer science department. I am still Aaron Clausen. I know. Sean Basler is still the brains behind the operation, cameraman, YouTube expert, and everything other than literally what you see here. Up until this point in this video series, we've been talking about very simple C functions and how they get realized in assembly. And we're at this point able to write assembly functions for very simple, a function that returns 5, or maybe adds 2 arguments or subtracts 1 from its argument. What we need next is conditional execution, and what I'm talking about here are if statements. So as an example, let's look at a function that just returns true, or it's going to return 1, if the argument that's provided is, say, the value 2. And you could do this as just a simple expression, return x equals 2. Now the point here is to understand how if statements are realized, so let's write it as an if statement. So we're going to have a int z Okay, do we really need the local variable? Probably not. I could have thrown the return statement into both arms of the if statement, but this is going to work for our purposes. Now here's the first thing we need to do when we look at a function like this, and it's something we haven't needed to do so far, is identify what compilers call basic blocks. Now a basic block is a chunk of code that gets executed all together. Now that doesn't necessarily mean they get executed all at the same time, but they get executed under the same preconditions. So for our function as we come in, creating this variable gets executed along with figuring out this comparison. Does x equal 2? Those two things always happen together. If one happens, the other one happens. So they're sort of tied together into what we call a basic block. Then we have this very simple basic block, this very simple basic block, and that very simple basic block. So we have 4 blocks here that we're working with. And the idea behind the basic blocks is we can actually encode them in assembly one at a time and then link them together. And so there's actually a little graph here. If we label these, I'm going to call this B1, B2, B3, and B4. Right? There's a graph sitting here that looks like this. Whenever the function gets called, you're going to execute basic block 1. Always. Then, depending on if this expression is true or false, you're going to execute either B2 or B3. And you finish executing those 2 basic blocks, whichever one got executed, and then you fall into block 4. And then that runs, and that's simply just making an assignment to EAX and returning from the function. Okay. Hang on to this picture as we start building the assembly. So in our assembly we have labels, and we label our function. Well, our function also happens to be block 1. It's where we start. So we can actually put the 2 labels right next to each other, and they actually mean the same address in memory. Usually we omit the basic block 1, but let's put it in there today. So the first thing I need to do is my function entry stuff. So I need to push long EBP. I need to subtract long, move long ESP EBP. This is just the normal function entry instructions. And now I need to make space for my local variable. This is where that subtract comes in. this subtract, it's actually making space for that int, or that int z. And the truth is, however many arguments you, or however many local variables you've got, they all get bundled into one subtraction. So now I need to do this comparison. How does x compare to 2? This actually is kind of interesting. There's a new instruction that we need, and it's called compare. CMP long. And this always seems backwards to me. I want to compare how x and 2 compare, so I'm actually going to compare them the other way around. So it's the literal value 2 and x. Well, x is an argument, so I have to actually go into the stack to get it. And I need to use one of these complicated addressing schemes that we talked about 3 or 4 videos ago. So what I want to do is I want to move 8 off of EBP to go find x. So this is what 8 off of EBP means. Perhaps that arrow should have been drawn the other direction. So compare doesn't modify any of its arguments. It certainly can't modify literal 2, because that would be weird. And it's not going to modify x. It actually sets another register that we don't have direct access to, called the flags register. Compare does all kinds of comparisons. It compares to see if x equals 2, if x is greater than 2, if x is less than 2. And it also makes those comparisons in both a signed and unsigned way. Because compare hasn't been told that x is a signed value or unsigned value. It's just a bit pattern. So it's the next instruction that's important. I want to jump. And I want to jump to skip parts of the code, so I only execute parts conditionally. Typically, basic block 2 will appear next. So where the if statement is asking, does x equal 2? If x equals 2, execute block 2. In assembly, we ask the opposite question. So I want to ask not, do I execute block 2, but do I skip to block 3? So compare has set flags, however it needs to set them. And then I want to do a conditional jump, J. JNE. This is jump not equal. There's nothing in the code, nothing in the assembly that connects these two together other than this sets flags and the jump not equals reads the flags. So in my case, I want to jump not equal to block 3. So I come down here, I create a function, I create space for local variables, I compare x and 2. If they're not equal, I'm going to jump to block 3. If they are equal, I'm just going to go ahead and fall into block 2. So here's my block 2. Block 2 is very simple. I'm going to assign 1 to z. And remember, 8 above EBP is our first argument. 4 below EBP is our first local variable. So this is going to be minus 4 EBP. That's z. And I'm going to create the same little arrow. Still probably pointing the wrong direction. That's it for basic block 2. Very simple. I made an assignment. Well, now that I've gotten to here in the code, I want to jump over the else case and jump into block 4. This isn't a conditional jump, this is just jump. I'm going to jump to block 4. So here I can put block 3. Which is just moving a 0 into z. That's exactly what we've got here. And the else is going to fall exactly into block 4. So now I can just put down block 4. Which is just moving z into EAX. And then it's just the normal function exit, leave, return. Which really isn't that interesting. We've talked about leave and return for the last hour, I don't know how many videos. But now we can actually see where the blocks break out. So all of this corresponds to that block right there. That's block 1. This is block 2. This one instruction is block 3, and then the rest of the function, setting the return value, is block 4. Now, this is a very simple example, but the truth is this is what the compiler is doing, and this is really all you need for conditional execution. I need to identify what my blocks in my code are, and it includes the comparison, because this always gets checked. That's the compare. And then we decide if we're going to do block 2 or block 3 or whatever blocks you have in your code, and they both come back together in block 4 and continue executing. So this is nice conditional execution. What we'll see next time is how we encode loops. We're going to see while loops and for loops. Do loops are actually very simple. So stay tuned, and we'll do more jumps next time.